In this video, we're going to talk about applications that utilize inequalities. First, I want to review the steps for problem solving. If you want some more detailed information on this, you'll want to go back to my other video called Linear Applications Perimeter. But the steps are basically you want to read the problem twice, make sure that you understand what's in it. Always start by assigning a variable to the value you're looking for. Then you need to go through, identify other important information. Are there formulas you need? Are there relationships between parts of the problem? And you'll want to make note of those. Sometimes you'll want to underline them. Once you have all that, you need to work on building your equation. Once you have your equation, of course, you want to solve it. You should always verify your answer is correct by substituting it back into the equation. And the last step should always be look at the original application and decide if your answer is reasonable in the given situation. So if you're doing measurements and you're measuring how long something is and your answer is negative, that's not reasonable. So you might want to take a look at your work. Let's take a look at this two-part question that utilizes inequalities. A computer science major's average salary after graduating from college is given by the formula of S equals 60,000 plus 2,000 T, where T stands for the years worked after college. How many years would a computer science major expect to work to earn $96,600 a year? Round to the nearest tenth. The second part of this question reads, a mathematics major's average salary after graduating from college is given by the formula of S equals 50,100 plus 2,500 T. Again, T stands for the years worked after college. If the math major and computer science major start working at the same time, how many years will it take for the math major to earn at least the same amount as the computer science major? Let's take a look at the first part of this question. We can see here that we have a formula of S equals 60,000 plus 2,000 T, and that's going to give us the formula for the salary. So we're going to need to start with that. So I'm going to go ahead and write the salary down here. The salary is equal to 60,000 plus 2,000 T. Now, we're saying that the salary needs to be at least 96,600. So I need to make this into an inequality. So I need to think about this. I want this value here to be at least, if not larger, than 96,600. So to do that, I need to make this into the 96,600 would be less than or equal to the amount on the right, because this represents the salary he's making based on the years. Okay. Once we have that set up, well, then it's just a matter of solving. So let's go ahead and subtract 60,000 from both sides. That gives us 36,600 equals 2,000 T. Divide both sides by 2,000. And our value is going to be T must be greater than or equal to 18.3 years. So that means that this person needs to work at least 18.3 years in order to be earning at least 96,600 a year. Now let's take a look at the next example. So here's part 2. Mathematics major's average salary after graduating from college is given by the formula of S equals 50,100 plus 2,500 T. So that's our mathematics salary. We know the computer science salary from the other side, which told us it was 60,000 plus 2,000 T. You'll notice here that they're asking us to compare the math major and the computer science major. We want to find out if they start working at the same time, how many years will it take for the math major to earn at least the same amount as the computer science major? So the amount we did before, the 96,600, has nothing to do with this question. That was just for the computer science major. So here we're needing to compare these two formulas. So let's go ahead and write down the formula for the mathematics major, and we're going to compare it to the computer science major. So we know that from the previous page of 60,000 plus 2,000 T. So what we're asking is, we know this again, let's write this here. This is our math major. This is our computer science major. We want to know when the math major is going to be at least the same amount or more than the computer science. So I'm going to write this as, when is the math side going to be greater than or equal to at least the computer science side? That's the setup for this equation, because again, we're comparing the two salaries that are only given by formulas. So now you're going to have to go through and solve this. Now, since I like to have my variables positive, I'm going to go ahead and I'm going to move the 50,000 from this side over to the right. And that's going to get me 9,900. It cancels, which means I'm going to take the 2,000 T and subtract it from this side. So I'm going to get over here 500 positive T is still greater than or equal to 9,900. Divide both sides by 500. So T, the years, has to be greater than or equal to 19.8 years. And again, we need to remember to label our answers. We want to add the word years onto this.